Tom, thank you so much for joining us.
Thanks, Zach.
Now, I think it's incredible that Web Summit has chosen to kick off with what I would call a pretty nerdy topic, but let's not assume everyone knows what we're talking about here when we talk about small models and specifically small LM, the Hugging Face family of models. Could you just explain it to start off?
Yeah, for sure. I think it's a very new trend. For a long time, we had the discussion, bigger models, right, are better for everyone, and you would get used to call this API. What we discovered, I think, over the past few months, is that small models can also work really well. They can do a lot of the tasks we thought only large models could do. And there's a lot of advantages to using them. You can have them, if you think about it, it's kind of a game changer. You can have them running on your laptop. You can have them running even on your smartphone. And in the future, you can have running them basically, I see them running in almost every tool or appliance that we have, right? Just like today, our fridge is connected to the internet. It's probable that our fridge would have an AI model running in the future, and it's going to be a small model.
All right, well, I want to come back to what my fridge is going to look like. But as you said, the narrative out there in the AI world more broadly is more compute, more data, bigger models with 400 billion parameters and more. I think there's been one model out recently with over 1 trillion parameters. You're talking about models that are orders of magnitude smaller. Why should we even be caring about that?
Because I think for a lot of very interesting tasks that we could automate with AI, we don't need to have a model that can solve the Riemann conjecture or general relativity, right? There's a lot of tasks that are very useful to run through an AI model, like data wrangling, like simple image processing, recognizing, maybe describing images, speech. All of this model, what we discovered that they don't need to be 1 trillion parameter. And they can even be quite general. So the model we released a couple of weeks ago, but we are not the only one. I mean, almost every open source company, at least, has been releasing smaller and smaller models this year. And what we discovered is that, for instance, the performance of a model, a Llama 1B model, so 1 billion parameters of this year, is equivalent, if not better, than the performance of a 10 billion parameters model of last year. So you have a 10 times smaller model that can reach roughly similar performance.
So what's going on in the training and model development that's allowing Meta, in that case, to get their models smaller and maintain performance, and obviously Hugging Face doing something similar?
I think a lot of the knowledge we discovered for large language model can actually be translated to smaller models. So we train them for much longer. We train them on very specific data sets that are, I mean, specific but still huge, but that are adapts for these smaller models. Slightly simpler, with some form of adaptation that's tailored for this model. And for some reason, it hasn't been pushed too much by closed source company or the leading closed source company, I think because they don't really want you to have the model running on your laptop for some reason.
Well, right. It's a proprietary model.
Exactly.
Your definition, or I'll let you define it. How does Hugging Face define open source when it comes to AI models?
Oh yeah, it's a big question. Also because open source is this very loaded word.
Yes.
I think it's a full spectrum. So I'm not open source absolutist. Like I don't think everything should be open, and also I don't think open source models should not be regulated at all. But I think what is interesting is as you start giving the weights. So we usually call that open weights model, which means you give the weights, but maybe you don't give all the training code or all the training data information. Just doing this act allow a lot of new application, like a lot of this application around adapting a model for your specific use case. For instance, fine-tuning a model, as I was saying, embedding it in a smartphone. All of these start to be possible when you give the weight. So I think it's a first step that really unlock a lot of potential. And then there is this idea of sharing more around what data you use to train or what code you use to train. And I think this is very interesting in terms of what I call open science, which means basically not considering our AI research as closed island, but basically as a whole community endeavor, a bit like physics research is, where we communicate our discoveries so that other team can also make new discovery on top of it. But I don't think every team has to do open science. Though that's what we do at
I think
Hugging Face.
you're among the only ones
Yeah.
being that open. So in terms of, so small LM is both open weight and open data in terms of the data that was used to train it. Talk a little bit about that data set. What are the core elements used to train a small model like this one?
So the pre-training phase is quite similar to a large model. The main difference is that we have kind of a physical law that explains what is the optimal size of the model in the training data sets. And with small LM, we go way beyond this optimal. We go 67 times to 200 times longer. So we would take a model that's what we call overtrained, but for a huge amount of time. So it's not especially efficient at training time in terms of optimizing performance versus size, but it allows you to get these models that are much smaller. So when you start to use them, when you are at inference time, then you get all the benefits of a smaller model. Yeah.
And just to drive it home, like if you want to go find small LM on your phone right now, you could run it right on the browser.
Yeah.
It's that small. It might eat up a little bit of your data plan, but it's so you talked about advantages like privacy, speed, lower cost. Am I missing any?
One example is I take often because I really believe it's going to be big next year is robotics. We want to deploy models in robots that are smarter, so we can start having robots that are not only on assembly lines, but also in the wild, like small robots working on stage here, maybe helping us a little bit. You need a low latency for that. You cannot wait 2 seconds like GPT that your robots understand what's happening. And the only way we can do that is through small language models. So it's going to unlock application of AI we don't even have today.
Well, I buy that the models need to be running on the edge, on device, for that to be possible, and I assume that's going to be true for autonomous vehicles and so forth. But why do they have to be small models?
It's just a question of compute time.
Speed of inference.
Speed,
okay.
yeah. I think we'll have these two trends progressing. On the one hand, we'll have this huge frontier model that will keep getting bigger because the ultimate goal is to do things that human cannot do, right? Like new scientific discoveries, this type of thing. This will keep being very large model. But it is the whole long tail of AI application, which I think is huge, will be, according to me, AI basically being embedded a bit everywhere. Like we have today, the internet is embedded everywhere in our life, right? It's not like we have one place where you have the internet. It's like a lot of small applications everywhere that are useful to call a taxi, like to know, okay, which restaurant I should go to. And we have a lot of AI models that are like this. They're not Einstein level, but they can do a lot of very useful tasks, almost at a human level, and they can understand what we say. And this will be all powered by small model, more or less specialized, some like chatbot generalized, some very specialized on one.
Vision of a future where me as a user, correct me if I'm wrong, you're saying maybe I have a bunch of small models running on my laptop and apparently in my fridge too. I could imagine that being quite difficult to manage. One reason people turn to just throw every challenge at GPT-4o, even if it's very simple, is it's one place to go, and you don't have to think about the models. How are we going to get from a pretty nascent, nerdy area we're in now to that vision?
Yes, I can go even more in the nerdy stuff, but you have some interesting thing about this small model. You can have like adapters, which are very tiny neural net that you put inside the small model. So the small model itself, we call it small, but it's like 1 gigabyte. So it's our CD-ROM in the past, yeah. And you have even smaller model that you add into it and that specialize it. And so basically, these are called QLoRa. It's a bit like putting a hat for a specific task that you're going to do. I put my cooking hat on, and I'm a cook. And so small model is you with a couple of hats in your bag. And this is one way to do that. So on your phone, you will have one small model, a couple of hats that I can put on, summarization. Now I'm a translator. And this is one way to do that, yeah.
That's very interesting. And is your hope that by creating this, or at least nurturing the open source ecosystem around AI development, that you'll see the community build those solutions, those
Yeah,
hats?
for sure. That's what we see already. So a lot of these models that are shared on Hugging Face, our platform to share models, what we see is that there is whole families of models being built on top of them. So you can see on Hugging Face, it's quite nice. You can see a graph where you see the base model, and you have a graph with all the models that the community fine-tuned for specific application. And it can range from, like, some of these models have thousands, several thousands of derivative models that have been built, trained on specific legal data sets, medical data sets, like all of this. So you see already this family growing. And the nice thing is, because these models are pretty small as well, they're accessible for many companies to, it's possible to fine-tune them on like decent hardware. You don't need like a 100,000 GPU data center,
Right.
which is great. And there is a future where you don't even need GPU anymore, and you can have just your regular computer network in a company that can be used to fine-tune this model and adapt them for your use case.
Pretty much everything you're saying, it flies in the face of the broader narrative out there. As I said before, more compute, more data, bigger models. But there are starting to be some doubts about that dynamic. There was a report in The Information that just this weekend that OpenAI and other major foundational model providers are seeing some plateauing of that they did not expect as they developed their latest models. Do you buy that? Does that ring true to you?
Yeah, it could be. I mean, there are definitely rumors. It's pretty clear that we've roughly exhausted the whole internet as training data, which seemed endless in the beginning, but there is actually just like a couple tens trillion tokens, at least of valuable quality data. So there was this trend of synthetic data set. We've decided that you can use the language model to generate good quality data, and we see that. That's why we use them, right? They generate things that we estimate are pretty good, and the web is actually starting to look more and more like a synthetic data set. But probably what we've discovered, at least in our experiments at Hugging Face, we did a lot of experiments on synthetic data set at the beginning of the year, was that it's quite useful for specific fields. So, for instance, in math, in code, you can generate good quality synthetic data that you can use to improve your model performance. Another area where it works really well is you have a specific use case in your company. You have a couple of documents, that illustrate your use case. You can generate very quickly a synthetic data set to train a model to adapt it on your specific domain. But what I think we don't really see is this very general improvement where a model would generate data that is of so good quality that by training a new model on top of it, you could climb the general scale of intelligence, where your model, generates some Einstein-level science, and then the next model generates some post-Einstein level science. I don't think we really observed that in the end. Yeah.
Yeah, that theory never made sense to me, so it
A lot of people
affirms my
hope for
pride.
that. Yeah.
You are using some synthetic data for small LLM, right?
Yeah, it's extremely useful for specific field, and in particular for code or math, it's really, really useful.
So one of the data sets used to train it is essentially synthetic textbooks. So correct me if I'm wrong, but there were original textbooks that Mistral, in this case, used to train its large language models, and which made it very good at producing synthetic textbooks that are accurate but originally presented. And that data is now being used to train not only small LLM, but other models?
So that was the original idea, and that's how we started a couple of months ago, or 6 months ago. We started with this idea of generating synthetic textbooks. So you asked GPT to generate, something on physics or biology for this level. What we discovered, though, is by carefully filtering the web and actually being more careful, you can even reach better quality. So we scaled back quite our effort on this.
Filter how?
So you filter it with a language model. Basically, you take every web page and you ask a GPT, is it good quality data? Which makes sense in the end.
And so the filtering for quality defined as accurate?
Education content, for instance. You can explain very clearly, I want something that's educative, that's clear, that's unambiguous, and you ask a GPT, or in our case, well, Llama, I think, to generate basically some scores for each page of the web. And the language model is quite good at unearthing the data that's good for itself as training data.
Got it. So a lot of what you're talking about, to me, feels like the building blocks of the agentic AI future that has become the latest buzzword. And that is like your notion of putting on a different hat for each specific use case.
Yeah.
What's missing for on the consumer side that would make that really accessible? So that my fridge actually could switch hats depending on the context.
Honestly, it's almost there, I think. There's just like integration work. I think we're really, this year and next year, we start to see that we move from this stage of really fundamental research on LLM to this year of basically thinking how we really integrate them. So for instance, in the case of the fridge or this small LM, a lot of the case what we want is give them a couple of tools so that they can actually not do everything themselves, but then call a tool that will do specific things. For the fridge, would be like a tool, like an API call, order back milk when I don't have milk anymore in my fridge.
Right.
And that's something we worked and a lot of people work, which is this small language model. You want to give them a couple of tools that just make them like we human can use tool. And then the question is, which tool, how you integrate, and that's most
consumer side that would make that really accessible. So that my fridge actually could switch hats depending on the context.
Honestly, it's almost there, I think. There's just like integration work. I think we're really, this year and next year, we start to see that we move from this stage of really fundamental research on LLM to this year of basically thinking how we really integrate them. So for instance, in the case of the fridge or this small LM, a lot of the case what we want is give them a couple of tools so that they can actually not do everything themselves, but then call a tool that will do specific things. For the fridge, would be like a tool, like an API call, order back milk when I don't have milk anymore in my fridge.
Right.
And that's something we worked and a lot of people work, which is this small language model. You want to give them a couple of tools that just make them like we human can use tool. And then the question is, which tool, how you integrate, and that's mostly engineering work. Yeah.
Were we talking about like a registry of small models, maybe that other small models can access when necessary?
Yeah, or just a registry or action they can do in the world. I think maybe more interested is this dream idea of an AI, like using everything we use and maybe being agentic and this. But I think much more useful is you define a set of tools that's very interesting for your task, and you train your AI so it know how to use these couple of tools in your kitchen or your appliance somehow, And that's where I think we're going to go.
Great. Well, Tom, this is super fascinating. I look forward to maybe not a small model in my refrigerator, but certainly a lot of small models on my laptop and phone in the future. Thanks so much.
Thanks, Zach.